Hi everyone, thank you for joining today. We'll get started in just a second. Okay, I might jump in. Thank you all so much for coming today. This is our webinar Fencing Farm Dance. I'm Tani Burgess, the Carbon Farming Outreach Program Coordinator. This is the latest webinar covering the benefits of understanding carbon and protecting natural assets on your farm. Working together with AgVic and the 10 catchment management authorities, the Carbon Farming Outreach Program has been running events across the state to assist Victorian farmers to understand their emissions. Today, we've got some incredible experts here to talk about teal carbon and the benefits of healthy wetlands and dams on farms. Thank you guys all so much for joining me. First, I'd like to respectfully acknowledge the traditional owners of the lands on which the work of Landcare Victoria occurs. We're inspired by the legacy of Aboriginal and Torres Strait Islander people as this land's first custodians and land carers. Today, I'm coming to you from Naarm on Wurundjeri country and pay my respect to elders past and present. As a quick reminder, you can ask your questions at any point through the presentations through the Q&A function. I know we're going to have a lot of questions today, so getting them in early will mean we're more likely to get to them. And you can also upvote and comment on other questions. My colleague Anna is also here to help with this. But first, let me introduce our first speaker. Dr. Martino Malerba is a senior lecturer at RMIT University. His team works with the Centre for Nature Positive Solutions. His laboratory studies cover freshland wetlands, both natural and artificial. He collaborates with the Australian National Carbon Inventory Team to model carbon emissions from freshwater systems and develop innovative financial incentives such as carbon credit methodologies to promote wetland restoration and management. Martino, thank you so much for joining us today. I'll pass over to you.
Hello, everyone. Hi. Thank you, Tony, for the nice introduction. So let me go ahead and share my screen. Okay, I believe you can see my slides. If not, just yell out. Right, so before we start, I also want to acknowledge the traditional custodians of the land, in particular the Woi-wurrung and Boon-wurrung language group of the Eastern Kulin Nation. So, as Tani was saying, I work at RMIT University in Melbourne, and I am part of a center called the Center for Nature Positive Solutions. And we pride ourselves for running projects that are applied and that are focused on helping the community that we serve. In my case, that is farmers. So in the center, we have several projects, and I lead the part related to teal carbon. That's carbon associated with freshwater environments. So and many of you might have heard before of the term blue carbon. That's carbon associated with coastal environments. We're talking about the mangroves, the salt marsh, the seagrass. Well, teal carbon is like the younger sister of blue carbon. It has the same principles of nature-based solutions to help sequester carbon and store in the sediments as well as reduce emissions. But instead of being applied to marine environment, is applied to freshwater environments. And these can be both natural or artificial. So naturals, we're talking about the natural wetlands, the rivers and the lakes. The artificial ones we're referring to as, the farm dams, as well as the reservoirs and even the wastewater treatment plants. So in my laboratory, we focus on these three major groups: farm dams, natural wetlands, and wastewater treatment lagoons. So today I'm going to focus on farm dams. So you all know what farm dams are. They are artificial systems that are built to support agricultural productivity, to improve water security. And we all know that we have a lot of them in Australia. Every time you fly to Sydney, Melbourne, Brisbane, when you look down as you're landing, you see all these kind of glimmering dots all around the landscape. It feels like they're like an infinite number. And these are farm dams. interestingly, when we started our project in teal carbon associated with farm dams, we started looking at the most basic information about farm dams. And that is, for example, how many farm dams do we have in Australia? Where are farm dams in Australia? Turns out that after a brief meta-analysis literature review, we understand that there were all sorts of contrasting reports and estimates ranging from several millions to 500,000. And the one thing that all of these sources had in common is that none of them provided any analysis or any data to support the simple questions of how many farm dams we have in Australia. So this is where we started. In early 2020, we published the first data sets of how many farm dams we have and where they are. So that's almost like a census of farm dams, and we use remote sensing. We now know that we are approximately 1.76 million farm dams. They cover an area of 5,000 square kilometers. To put it in context, that's a small European country. And they store we estimated that all these farm dams together, they store around 20 times the water of Sydney Harbour. This information is packaged in this website that we developed called housedams.org. There is in this interactive website where you can zoom in and out anywhere in Australia, and it shows not just the distribution of farm dams, but also a few basic statistics on total estimated water capacity, surface area, etc. But this was just a start, because really what we were interested in is the impact of farm dams in the environment. And so the initial stages were just to understand the scope of opportunity. What we were really interested in are aspects such as mainly carbon footprint, biodiversity, water security, and energy. Today, I'm going to focus on the first two, carbon footprint and biodiversity, but feel free to ask me after the seminar about other aspects that I don't have time to cover today. So let's start with carbon footprint. Okay, what you see here is a video of what it looks like a farm dam in a rainy day, except in that day, there was absolutely no rain. What you're seeing here are bubbles that come from the sediment up. And these bubbles are nearly 100% methane. This process is called methanogenesis, and it's relatively normal and natural because any freshwater system tend to have some degree of methane productivity. But what we found soon enough is that when you measure emissions from farm dams, well, they punch above their weight. So per square meter, they emit 4 to 5 times the equivalent of like what it could be a natural wetlands or reservoirs or other systems. So this was the start. So interestingly, this was published in 2018. This was the very first study measuring any type of greenhouse gas emissions from farm dam. So the field is pretty recent. And so the next question we asked is, okay, well, farm dams come, as you know, in all shapes and forms. So it's very hard to generalize something across all farm dams. For example, in this case, you can see a range of farm dams that go from, something that is well vegetated, nice, green, lush, all the way to instead something that is bare, with muddy water, with livestock walking in and out. So clearly the processes acting in these two different types of farm dams are pretty different. So we partnered with another group in Australia studying farm dams. They are the Sustainable Farms at Australian National University. They focus on biodiversity. So we partner up and we started this really large field trip across Victoria, New South Wales, and even Queensland, where we were monitoring a range of farm dams. Each dot here is a property, and for each property, we were particularly interested in the comparison between sites that are fenced and sites that are unfenced. So the unfenced are called the control or unmanaged farm dams, or you can call it the open farm dams. And the fenced ones are the managed farm dams, or also known as enhanced farm dams or fenced farm dams. It's important to know that the second group, the enhanced farm dams, they don't all have the same level of management. Most of them have a fence to exclude livestock, but some have a full fence with a, say, a pump connected to a trough. Others have a partial fence with a hardened access point, and you have different degrees of management. So we went around and we started monitoring what is the benefit of fencing a farm dam for water quality. And so we measured nitrogen, and we found that on average, fenced farm dams have 32% less nitrogen than open farm dams or unfenced farm dams. Similarly, fenced farm dams have 39% reduction in phosphorus. We also found that fenced farm dams on average have higher level of dissolved oxygen. This is an important piece of information when it comes to greenhouse gases, because dissolved oxygen is a key driver of methane. The more dissolved oxygen, the less methane you have. And so, well, at the time it was surprising, but in hindsight, given the dissolved oxygen, it's probably not that surprising. We found that fenced farm dams have on average 56% less methane than open farm dam. That's more than half. And so all these findings were published in quite an exclusive journal called Global Change Biology. That's like a scientific journal that publishes the top findings internationally about biology and environmental sciences. And this is kind of the interpretation of the data. So the moment that you install a fence to limit livestock, then what you're doing indirectly is you're promoting vegetation. This vegetation creates a biofiltration effect that limits the amount of particles and nutrients that get inside the farm dam. And because of that, you have a reduction in nitrogen, in phosphorus, and an increase in dissolved oxygen. So overall, an improvement in water quality. And this improvement in water quality leads the 56% reduction in methane. We drilled more in the data, and we found that, as I was saying, dissolved oxygen is a key parameter. So much so that we found that when you get to dissolved oxygens of around 10, which is pretty high, what we found is that the greenhouse gas emissions turned from what it was a carbon source to a carbon sink. Meaning that, if you want an analogy, like low dissolved oxygen means that your farm dam acts as a chimney emitting greenhouse gases. When the management allows for high dissolved oxygen, then your farm dam reverses the cycle, the flow, and it becomes a carbon sink. And it starts to absorb carbon from the atmosphere. Now, after many years studying farm dams, I guess it's understandable. These results are pretty understandable. And just recently, I found a photo that really captures what I'm talking about. So this was field trip that I took probably less than a month ago, and there was like a partial fencing. Half of the farm dam was fenced, and the other one was open. And as you can see, the vegetation, well, it's non-existing, as you would expect when you have like hundreds of kilos worth of livestock walking on top of vegetation. It soon disappears. And this is exactly the process that we found, and how it affects carbon. So again, working together with Sustainable Farms and Australian National University, we put together pamphlets of all of these management interventions that we suggest for farmers to consider, that have all the common goal of improving water quality, improving biodiversity, and also having benefits for greenhouse gases. And so at the end of my presentation, I have a QR code linking to this PDF that you can find online. But these interventions include, aspects such as, a shelter belt to reduce evaporation, having a dense grassy area to again create that nice biofiltration effect, the fences, the water troughs, the hardened access points, and so on and so forth. Okay, so let me go a bit in a small little tangent that I very much like. So this was a snapshot of the video that I showed before of us measuring emissions from farm dams. And up there is the research assistant collecting data. Here top left is the instrument that we used at the time. That was when we kind of at the beginning of our farm dam work. That is a commercial greenhouse gas analyzer that we carry in a beach cart. It weighs around 50 kilos, and it's connected to a floating chamber. That's how you can trap emissions coming out from aquatic systems, run these emissions through the machine, and measure the concentration, right? And this is, again, us working on different systems. Sometimes you cannot bring the cart, so you need to have this box. So as you can see, it's quite a complex piece of equipment, and especially is extremely labor intensive. And critically, you can only measure, say, like a few hours worth of emissions for each farm dam, because otherwise it becomes unfeasible. Well, this is very important because emissions vary a lot. They change between day and night. They change between summer and winter. They change before and after a rainfall event. So it is problematic to rely on snapshot survey because the same farm dam, if you go there on a cold day, will measure completely different values compared to a warm day. So given this, we spent several years working with an engineering company to create what we think is the right piece of equipment that we need to monitor emissions. And this is, we call it the Pondi sensor, and it's unique. It doesn't exist commercially. And what it is it's basically much of the same technology as a mobile phone, so basically connection to the cloud, the batteries, solar panel to recharge the batteries. It's just that all of this is packaged with on top of a bucket, a floating bucket that we buy at Bunnings, with greenhouse gas sensors inside. This is how it looks in real life. So the whole system costs a fraction of a commercial system, and it's all built from parts. Again, it took several years. This is the prototype, the first iteration of the prototype, and it has changed dramatically since. And what this piece of equipment enables us is that we can deploy these pondis in water bodies, and then we can then log into a platform and accumulate and see the data streaming in. This allows us to, for the first time, collect data on an hourly basis automatically from several sensors at once. As you can imagine, this was quite a revolutionary innovation. So this is a follow-up study on, again, the benefit of farm dams, fencing farm dams. But this time, we relied on 84,000 hourly observations from 113 farm dams. So it's like a massive data set. And with this data set, we could explore a lot more than just the average. But for example, we could break it down season by season. We found that in winter, we have a fraction of the emissions that we have in summer. So we're talking about 1 to 10 kilograms of methane per hectare per year against what it's like 50 to 500 in summer. So like order of magnitude higher. We could also use this data to model the scope of opportunity to improve farm dams for emission reduction across the entire Southeast, including Tasmania. And this data was important because it allows us to create a model that is now implemented in the National Inventory Report. This is a document that Australia is obligated to compile and submit once a year as part of Paris Agreement. And now, for the first time, we have, well, since 2022, we now have emissions from farm dams that are listed as part of all of the anthropogenic emissions that Australia produces. So while, of course, well, emissions from farm dams, they don't scale to many other emissions that we produce, and they are just a tiny fraction. But the importance of having these emissions officially recorded is that now we can talk about methods to try to reduce these emissions. And one of the most obvious ones is carbon credits. I'm involved in two methodologies that are being under examinations from the federal government, where we estimate, we try to understand how we can award carbon credits to farmers in exchange for management interventions to improve the condition of the farm dam and also reduce emissions as a consequence of that. And the reason why I'm passionate about this work is because fencing farm dams might reduce emissions, but it also does a lot of other co-benefits. Better water quality for livestock, biodiversity benefits, better water security. So literally, like, the only barrier is the cost of managing a farm dam. So if we can find a way to help farmer out and reduce this barrier, then I feel like everyone is gonna be on the same side here. I mean, I like to think so. So sometimes we cannot fence farm dams because there are constraints. Like either we cannot install a fence, or we cannot exclude areas from livestock. Well, another thing we're working on is a different management intervention. This is called a floating wetland. It's much of the same theory. So again, using plants as a nature-based solutions. But this time, instead of having plants around a farm dam, we have plants growing on top of a farm dam, doing much of the same things, but this time using the root biomass to create a new area for bacteria to grow, and again help to improve water quality, reduce nutrients, and reduce emissions. This is a novel innovation. We are still collecting data to support the benefit of floating wetland for carbon. We're still at early stages. Also, we're working with different types of floating wetlands. For farm dams in particular, we started thinking about models that are plastic free and made of recyclable materials. And so the first prototype was made of pellets, and it cost like, less than, I don't know, what is it, $50 per, what is it, 2 square, like per pellet. Uh, and they grow pretty well. You see, like here on the left, what you can barely see is a full-grown African researcher, and and it's like literally hidden there. And yeah, it's amazing how much they grow. Um, yeah, see, these are other photos. We started looking at other designs, like improving both the aesthetic and functionality. So this is a different design. This is an experiment going on in the Basque Coast and is supported by Melbourne Water. Again, early stages. Another thing we're doing is think of what to do with the biomass from floating wetlands. And this is a startup based at RMIT that is using the biomass from some of these floating plants to create products such as t-shirts or coffee cups and the rest. Another floating wetland related project is using floating wetlands to improve wastewater treatment plants. So this is unrelated to farm dams, but again, it's the same idea. You have polluted water, like water with a lot of nutrients, you put plants on top and see what happens. So this is just a snapshot of how the system looks like. This is in Phillip Island. This is like almost the area of 2 tennis courts. And what you're seeing here is 2 corridors, and one corridor acts as the control, so nothing grows there, and the other corridor is where you have the floating wetland. And these are monthly photos over 2 years showing, let's see, the plant starting to grow. Again, this is a wastewater treatment plant, so there was an issue with toxicity at the start, but again, then plants managed to overcome the issue, and yeah, it's pretty lush. It's still there. It's in front of the MotoGP. So yeah. Right. I'm going to now talk about biodiversity. As I said, fencing farm dams by increasing vegetation offers many benefits, and one of them is creating habitats for wildlife. So, if you have a quick look at the scientific literature related to freshwater biodiversity, well, things are not great. You find statistics such as 70% of the world's wetlands are now lost since the 20th century. Freshwater biodiversity is declining faster than terrestrial and marine, and half of amphibian species are classified as threatened or near threatened. So our hypothesis was pretty simple. Some farm dams look pretty damn good. They are like lush, well vegetated. Could they offer what could be like the next best thing to a natural wetland? Could these farm dams offer, viable habitats for some of these endangered frog species? And so, to answer this question, we started a program called Frogs in Dams. So, this was a collaboration with Melbourne Water and Australian Museum. These two companies, for years, they have run citizen science projects where anyone can download an app on their phone, and then they can record the sound of frogs. And then this recording is then sent to a cloud, to a network, and it is then mapped and analyzed by experts. And over the years, they have collected millions of frog sightings across Australia. So the idea of this project was to overlap the frog distribution with the map of farm dams. And so now, for each farm dam, you could extract every time that someone detected a frog. And, and this was the resulting data set. So these are effectively just all the frogs associated with farm dams. we're talking about 104,000 audio recordings of 107 frog species from 8,800 farm dumps. And so the first thing we found is that many of the most threatened species in Australia, such as the growling grass frogs or the green and gold bell frogs, are often found in farm dumps. In fact, we have lots of recordings of these species. So we then crunched the number, used remote sensing to extract what are the typical characteristics of a farm dump that is associated on average with a lot of frog species. And this is the summary of the findings. So typically a lot of like high biodiversity in frogs is associated with farm dumps that are intermediate sizes, near, connected to other freshwater systems, connected with conservation areas, small catchments, and they are old. This was just a start. After that, we started collecting data from the field. Similarly to the carbon project, this time we were looking at, again, a paired experimental design of like fenced against an unfenced farm dump. But this time we were collecting data on biodiversity. And we used all sorts of proxies. We started with a traditional survey, then we started installing camera traps, song meters to record the sound of animals, eDNA as a way to extract DNA. And we put all these data set together and we found, again, not surprisingly, that like pretty much every single group of organisms shows higher biodiversity in fenced farm dumps. So the way to interpret this graph is everything that is above the dashed line means that fenced farm dumps have higher numbers on average than the unfenced farm dumps. The only group that seemed to be kind of 50-50 is the invertebrates. And also when we look at the functional groups, same thing. The majority, they show fenced farm dumps with a lot more species than open farm dumps. The only exception is decomposers and scavengers. Again, partly because you find a lot more, dead matter in open farm dumps. Right, so why this is important? Well, this feeds into, again, a similar narrative to the carbon credits, just this time with biodiversity credits. Again, as a way to break the cost barrier of managing or fencing a farm dump, can we then source inspiration from biodiversity credits? Can we help out farmers that manage their farm dumps by awarding them biodiversity or carbon credits? We also did a study looking at the methodological aspects of enabling such biodiversity credits. So how do you monitor biodiversity? Do you send a technician? Yes, but it's expensive. Do you put an acoustic recorder? That's a good idea, but it only captures acoustic species, like vocalizing species, like the frogs and the birds. Do you use eDNA? Well, it's kind of expensive. So anyway, we looked at all the trade-offs. What we found is that when you compare the different methodologies, well, passive acoustic monitoring or like audio recording is the one that works can detect the largest number of species, especially amphibian and birds. Then eDNA is good for fish and invertebrates, camera traps for mammals, in-person surveys for reptiles. We also looked at the cost benefits of the different methods, and turns out that passive acoustic monitoring can become also the cheapest method. And we went into some kind of flow chart of which method is best depending on the situation. Right, so the next thing that I'm really passionate about comes from personal experience. I live in the Yarra Valley, and every time I hear the sound of yellowtail black cockatoo, I get happy. I don't know. It's something that triggers me, and so I feel like I'm not unique. So part of this project now is to try to develop technology that allows you to feel biodiversity benefits as a function of some conservation management. And in this case, we are going through sound. So imagine a system, imagine a piece of technology that you install in a farm dump, say, and you install it before you do anything on the farm dump, and then you start, revegetating, fencing, and doing the lot. And this piece of technology allows you to then monitor how many species are detected near this system. And it can send you like daily updates or like weekly updates. And then what you can do is you can check the progress of number of species over time, as you progress your restoration, as the plants develop, as you have higher vegetation and all of that, I believe this can create a positive feedback, because you're not just doing restoration for restoration's sake, but you're seeing the benefits in real life. So this is the data sets that these type of prototypes that we have developed can give you. These are time series, like 4 months worth of daily time series of all of the birds and frogs that are automatically detected through AI, artificial intelligence, by analyzing these sounds. The technology is pretty good, but it's not perfect. So, for example, this is another study where we review the performance of AI for frogs and birds. And turns out that for some species, the AI is great, 100% accuracy. For other species, it's pretty bad. And so clearly there is scope for improvement here. I'm also really proud to say that in terms of the frogs, we published the first AI model that can recognize frog species. It was trained on species of the southeast. We call it the FrogNet, Vic FrogNet, and it's like an AI model that anyone can download. And in fact, here are the instructions that are attached to the paper that we downloaded, that we published. So the next question is, well, can environmental markets really pay for farm management? Like, what are we talking about? Are we talking about, like, subsidizing 1%, 10%, 100% of the cost of managing a farm? So, well, the first thing we did was we carried out a survey. And in this survey, we were getting a feeling of how much money would farmers like to get in exchange for managing their farmdom. So this was a survey that was shared across the Southeast Australia, and it kind of works like this. It's a proper method in social sciences. It's called the double bounded dichotomous choice contingent valuation. And I'm not a social scientist, but luckily I knew people that could make this work. But basically what happens is you send a survey to a farmer, and it says, okay, like, would you fence your farm up if you were given this amount? And it gives you, like, well, a random number in between a minimum and a maximum bound. So in this case was between $100 to $10,000, so something really, really low to something really, really high, right? And then, depending on the answer, like if the farmer says yes, then he would ask again, like, okay, would you also fence your farm up for something lower? And he would give another number. Or if the farmer says no, he would say, okay, what about something higher? And he would kind of adjust. And this is a method, so then you can use specific statistical techniques to then estimate this curve. There is the probability of farmers saying yes as a function of how much money you offer the farmer. And this is the curve that we published. So we found that around 25% of farmers don't really need any financial incentives. They say, yes, I want to fence my farm, it doesn't matter how much it costs. But then the interesting part is this one. 80% of farmers would accept fencing their farm for something around $1,500 per year. So that is kind of the magic number. So the reason why we published this study is because we wanted to make a compelling case that, hey, like we need to create a system where we can arrive to this number of $1,500 per year. That, in my opinion, is pretty low compared to all of the subsidies that the Australian government gives out. That we're talking about probably what it looks like a drop in the ocean. But anyway, this is the magic number. So the next question is, okay, how do we get there? So this other study is about calculating what could be the associated carbon credits for reducing emissions in farmlands. So in this study, we looked at the cost and the benefits, and we found that, well, yeah, if you look at carbon credits, it's not going to cut it. So that it definitely cannot cover the cost of fencing a farm. And in fact, like, if you put together everything over 30 years, there is a negative budget of around $20,000 if you fence your farm. This is assuming that there is carbon credits associated with that. So carbon credits alone is probably not enough. In fact, carbon credits give you very little, like 5,000 over 30 years. That is assuming current values for carbon credits. There is sits around what is $40 a ton. So not great. In fact, this turns it to $170 per year. But then something else happens. We found something, well, somewhat unexpected. So we found that if you want to find something that can pay the cost of fencing, don't look at carbon credits. Look at livestock weight gain. And what I mean is, every time you fence or manage a farm dam, you get better water quality. And turns out that no one has ever looked at how this better water quality translates into better productivity, especially for meat livestock. So we did a model and we estimated that as little as a 3% increase in livestock weight gain. So if your livestock grows as little as 3% faster, then that is gonna more than pay any kind of restoration for farm dams. In fact, we modeled it. Here we have on the x-axis how much faster livestock grows, and on the y-axis is how many units of livestock do you sell every year. So of course, if you sell very few units, then of course you need to have them to grow very fast. But in a typical situation, we're talking about say like 50 cattle sold per year. Well, if you are in the 50s, then as little as 2% will be more than enough to cover all your expenses related to improving your farm dam. So we don't have data for this, except there are two studies in Canada that looked at this, very preliminary, but they found that the estimated improved in livestock weight gain associated with improving water quality sits around 10 to 20%, depending on where you are. Like there is no data for Australia, and these are the only two studies worldwide. So again, this is an area where we have literally no evidence. But if we rely on this data, then between 10 and 20% livestock weight gain, it means that like automatically it pays off a lot more by providing better water quality. But again, this is an area that we would like to study more because yeah, there is virtually nothing there. Right. So as I said, I've already talked for almost 40 minutes. But as I said, I wasn't going to talk about water security and energy. The only thing I want to touch before I finish is this thing here. So, carbon footprint, biodiversity. How can we combine the two? Is there a way so then we can kind of use the same management for both? Well, what about dung beetles? So this is something I started working recently. There's a PhD student in my group looking at that, and we know that dung beetles are amazing and they do all sorts of things, and they can decompose dung, they can bury dung, they can process dung, they do all sorts of things. And dung is really the main ingredient that leads to contaminated water in your farm dam. So what we did was we looked at several species of dung beetles and we started looking at how they work. And it's incredible. Like you put something that looks like almost a kilo worth of dung in a small bucket, and within 2 days it's gone. So you can imagine the effect of having dung beetles around your farm dam. They have to be big. They have to be quite considerable. Again, we are in the process as we speak. We are collecting data in our laboratories, and I don't know the answer, but yeah, as I said, like Nipunika, the PhD student, is doing a great job, and I cannot wait to see the results of her experiments. That's it. With this, I just want a final thing. So again, this was a recent field work. Something else that I'm really passionate about, but I haven't had the chance to look into is the recreational value of farm dam. And this picture kind of shows it. So what you see here is a little jetty in a farm dam. And the farmer explained to me that a few years before, the daughter of the farmer wanted to get married next to the farm dam. And so the farmer built a jetty so then they could get married on the farm dam with all the guests around it. And this made me smile because again, like I'm convinced that better management of farm dams has, as I said, a lot of co-benefits, and one of these is recreational value. Having a nice space where you can go for walks or sit to look at the sunset or whatever, like listen to birds and frogs, like that. These are important, and again, there is literally no information in the scientific literature to estimate the kind of natural capital that well-kept farm dams can offer. And with this, I'm gonna finish here. Thank you very much. So my name is Martino Malerba. I'm at RMIT. Here is my email. Um, these are the QR codes for the resources offered by Sustainable Farms. And yeah, these are all the partners that enable this research. So yeah, any questions? I believe there is Q&A later. So thank you very much.
Thank you so much, Martino. I know that we all give a damn about farm dams here, but it's really wonderful to see all the different economic, environmental, on-farm benefits that they can have. And it's fabulous to share enthusiasm for both yellowtails and frogs, because I don't think you're alone in that on this call either. Um, a reminder, if you do have questions for Martino or any of our experts, I can already see the Q&A function going off. You can also upvote if you like other people's questions, comment as well. We really encourage you to get in early. But now I'm just going to pass over to someone who knows all about fencing farm dams and managing wetlands as well as carbon. Jen Smith, who's the General Manager with the Gippsland Agricultural Group, where she leads the rollout of the Carbon Farming Outreach Program across East Gippsland. Jen farms composite sheep and Angus cattle at Tambo Crossing and Clifton Creek with her husband Brad. She also volunteers with her local Tom's Creek Landcare Group. Jen, thank you so much for joining us today to talk about your journey through carbon and wetland restoration. I'll pass over to you. Jen, I think you might just still be muted there.
Great. Thanks, Tani. Just to check on that slideshow, that's up and running.
All looks great.
All right. My name's Jen, as Tani said. Thank you for the introduction. I farm sheep and cattle in the Victorian High Country and the Red Gum Plains with my husband Brad and our two trusty sidekicks, Tyson and Amy. Oh, yep, we're moving. Yeah, as I said, our country, we've got 71 of the 1.6 million dams that Martino just shared that we're in Australia. We've got some plains country and some hill country, so reticulating water around our farms and getting our cattle off our dams has been a journey that we've been on. I'm just going to share a little bit of my story, my carbon confusion, how we now think about dams and where we see it fitting into our future aspirations to be a beef and lamb production business that trades sustainably and maintains market access with what we believe is coming at us from a sustainability perspective. As I said, we started out farming 20 years ago. It was me and my husband and our trusty labour force. Over the years we have experienced drought and as well we've had 2 rounds of bushfires on our properties. So lots of challenges in addition to trying to navigate the carbon dimension that came at us. We've also had some tremendous years. We spent a lot of time and effort developing our feed base. We're really passionate about renovation programs to develop long-term, deep-rooted perennial pastures that work with a high-intensity rotational grazing system. And so stock water is a really key part of that, which I'll talk more to later. Brad and I are very active and have been for a long time. Started out our farming journey. Myself was a fair bit of a novice, but over the last 20 years, we've involved ourselves in Best Wool, Best Lamb, Better Beef, and also the Top Source program. I guess through that, our awareness and understanding of what was evolving in the carbon dimensions came. But I think the real wake up for us was an announcement from Meat and Livestock Australia there about sort of 10, 15 years ago around the aspirations for the red meat industry to be carbon neutral by 2030. We took that fairly seriously, as did a lot of other producers in our region, that this was a dimension that we were going to have to navigate in our businesses, and there were many aspects to it. We set a path. We decided that it was something that needed to happen, and we set a path of trying to understand how we actually, develop our intelligence and understanding of the carbon dimension, and how we play in the sandpit, with a lot of our products going into domestic and international markets that have that sustainability credential to them that would be attached with whichever way Meat and Livestock Australia kind of set up that carbon neutral brand or that sustainability brand for Australia. We still think that is something that is emerging, but we know that that's changed. The first thing that we did was to participate in the Melbourne University Nexus project. This was a project that worked right up and down the eastern seaboard of Australia, and what they wanted to do was to understand profitable, sustainable livestock businesses in an increasingly variable climate. Melbourne University research team wanted to basically case study a number of different typical enterprises and understand what the emissions intensity of those particular properties were, working through and map out what the emissions intensity would be under a number of different scenarios. So under that Nexus project, they studied our farm for a number of years. We took lots of data and lots of numbers and gave lots of information. We worked with a peer group of farmers to sort of, throw backwards and forwards with Brendan Cullen and Richard Eckert, the grandfather of carbon emissions in Australia, work with those guys around understanding how, we map and build that emissions intensity profile of a farm, and what would it take within our farming systems to kind of get them to carbon neutral. And towards carbon neutral, so the third line there's towards carbon neutral with forestry. Within our farming systems, with a couple of thousand sheep and 300 cattle at the time, we would need to plant 86 hectares of shining gum to be able to kind of offset our emissions. We felt pretty good and stable and steady that, that's a pathway that we would take within our farming systems to be able to participate in that carbon neutral. We've all seen over the years that landscape has changed, that goal of being carbon neutral by 2030 has been amended and changed. I think producers are still lacking that guidance and leadership about what that's actually going to look like in the future. When our farming system was mapped out, our production system is within the ranges of what they would expect in terms of emissions per live weight of beef, live weight of lamb, and live weight of wool. So we've got some work to do in different areas, and we've continued that work to improve our efficiency in that area. We've set ourselves up with some goals that we think that are reasonable to be able to achieve, and then possibly with the other addition of amendments or carbon offsets or credits or things, that when that time comes that we'll be in the best position to participate as much as anybody else in Australia. We've done a lot of work in Gippsland with Gippsland Agricultural Group, with Melbourne University and MLA to understand better carbon in our system and how things work at different times. And this work has been at times really invigorating and exciting, and we've felt maybe on the frontier of kind of what's happening. And at other times we've been utterly despondent and completely apathetic to what it is that we're actually going to be participating in as producers. The main things that stand out for us that I think have been valuable for us is to participate with good communicators like Richard Eckert, who communicate with producers in a way that we understand carbon and how it moves and plays in our system, and the things that we can do within our control to manipulate that. I've settled in over the last couple of years on the Agriculture Victoria Livestock Farm Monitor project, which also gives me an annual emissions profile. I believe that in 5 years' time, maybe 5 to 10 years' time, we'll have regional targets for emissions intensity within our farming systems, and we'll need to run a 5-year average for those. That's the program that we've picked, the Greenhouse Gas Farm Monitor project, and that's kind of how we're tackling it. This brings us to thinking about our farm dams and water reticulation. Those 71 dams over the last 14 years, we've set a path to eliminate them from our stock watering system. We think that removing the livestock from those, we have a lot of drought and bushfire conditions if you want to think about what happens to farm dams when the whole property is burnt and the palatability of that water and livestock performance, I can share some information and data from that. For us, and I'd just echo what Mario sort of spoke to before around live weight gain. There's been a number of studies that Meat and Livestock Australia, CSIRO, and DPI have done, and some of these studies in well managed farming systems, they're pushing well over 10 to 15% of gains in livestock weight gain. And when we sort of run a bit of a scenario through having our steers feeding out of farm dams that might be subpar, drought affected, bushfire affected, various other conditions, and we look at the value that we can actually put on each steer in our farm business, it's incredibly significant. The other factor around the farm dams for us is thinking about animal health, drenching programs and labour, drench resistance, vaccine resistance, immunity to various things is a really significant challenge that Meat and Livestock Australia are the problems that they're trying to find solutions for all the time. We feel that removing our livestock from those water sources has really significant gains for us. And as much as even the reduction in livestock deaths, I think, it's not a great thing for us to deal with, but having livestock that get stuck in our water sources is it's a real challenge and something that we need to be mindful of from a welfare and that social license to operate perspective. We also, with our deep-rooted perennial pasture, we want a high level of ability to be able to move livestock around our farming systems, to put them on and off pasture, to increase that pasture utilisation, to remove that livestock pressure from those paddocks and from those pastures when there's dry conditions or wet conditions as well. And having a really well set up water reticulation system around our farms is a key part of that. And it's been a big journey for us over the years. We just recently purchased a new block, and the first thing that we did was put a ring main around the entire farm and put troughs in every single paddock. And in our business, we feel like that it is one of the second to fencing. Reticulated water is one of the highest return on investments within our grazing system. The extra pasture utilisation and the extra weight gain increases our capacity to carry more animals and dilute our ever-increasing overheads within our sheep system. Year on year, we've seen 20% increase in lamb production per hectare by getting them off those dams and reticulating that water. And we believe, and this might be a bit of a big call, and Mike Lawrence from Meat and Livestock Australia challenges on me, but we believe a 30 to 50% reduction in disease risks when we think about worm burdens of things, and also fluke and things like that. It's been an expensive exercise to do that within our business, but we believe we're seeing sort of, about a 25% return on investment. And when we look at those live weight gains, to put real numbers to this, increasing our beef live weight gain by 23 kilos a hectare doesn't sound like a lot, but when you calculate that over the 1,000 hectares in our farming system, beef's trading at $5 a kilo at the moment. That's just a touch over $100,000 worth of beef from having that reticulated water system. If we look at sheep, and sheep prices are phenomenal at the moment, $11 a kilo. But if we run the same numbers and you're increasing that sheep production by 14 kilos a hectare based on the livestock farm monitor numbers that we're actually achieving, that's also a touch over $100,000 at $8 a kilo. Our farms have different profile. We've got really, really steep hill country, which produces lots of challenges in terms of water reticulation design and high pressure systems and the like. We've got one of our dams is 4.5 acres. Our kids think that it's a wonderful spot to get the canoes and kayaks out and put the water slide down. We think that this would be an incredible site, given its scale and its capacity within the landscape that it is to fence off and vegetate the whole thing. On one of our recent new blocks down on the Red Gum Plains of Gippsland, this is a highly fragmented system. The Plains country has been pretty much entirely cleared, and so remnant vegetation and that has high value communities still present in them, represents some pretty significant value for organisations like Greening Australia and the like to come in and do projects, and they find various plants and herbs and growling grass frogs and all of these things that these guys want to partner with us to protect that remnant vegetation, fence off areas, and help regenerate kind of what was naturally there. Last year, we worked with Greening Australia. They had a large investment opportunity with AstraZeneca from overseas, who wanted to fence off the entire farm, every dam on the farm, put in wildlife corridors, do the entire project, something like $800,000 worth of investment, if we were to give them the credits for the carbon credits for 15 years. We nearly did that. We nearly signed on, and because our aspiration to have that work done to improve, the amenity of the farm, the animal health, the biodiversity function of our farm is a really high priority for us. Our challenge was finding independent advice to give us advice about what are we going to need as methane exhibiting, emissions intensity farmers. What is it that we're going to need to be trading in, say, 10 years time or 15 years time? And there is absolutely no clarity for us around that. So we've taken a slightly different approach, and we're working slow and steady, keeping the credits for ourselves, working with Landcare, working with Greening Australia where we can on smaller areas. The area that you're looking at there is a 5-hectare low spot in our farm. Some really high value marsupials and frogs have been found in there, and also some herbs and grasses. So to reinstate that and fence that off, we do the fencing and the weed control, and they do the revegetation. This is going to be a much slower path to where we want to get to with our dams across all of our farms, but without the clarity that we think we need around what's going to happen with emissions intensity, carbon credits, what are we going to need, what is the biodiversity credential system that we are going to be trading in as producers. We don't have all of the information to confidently make decisions to do what we know pays from an animal production point of view, and what we know is going to be fantastic from a biodiversity perspective within our farms. It's not all pretty. A lot of it is ugly and slow work, and it's going to take time to repair the landscape. But with the information that we have right now around the carbon dimension, around what's happening within the biodiversity space, how we can monitor and measure things, these are the decisions that we sort of feel comfortable with. But we would really like, as producers, to be moving faster to getting every single one of those 71 dams fenced out of our production system and contributing to the biodiversity and overall health of our farms. Thanks, Tani.
Thanks, Jen. That was a really, really awesome presentation. It's so great to hear more about what you're doing on your property. And again, I don't think you're alone in finding so much value in protecting that biodiversity. I'm just going to really quickly hand over to Lisa McIntyre. She's the Panyabar Landcare Facilitator. I hope I pronounced that right. Not at all. I'm getting a shake of the head. All right. With her husband, Sean, they established the Panyabar, is that right? I'm getting all right, a lot of laughter. They established the Landcare Group in 1993 after they got married. Both the marriage and the group are still going strong, which is great. And Sean and Lisa still continue to work together on their self-replicating Angus cattle farm that's being regeneratively run at Caribou. Previously, they'd run superfine merinos, and Lisa is currently working with 7 local landcare groups and the surrounding landcare community, and also with the Natural Glenelg Trust as their partnership and community coordinator. Lisa, thank you so much for joining us tonight. I'm going to stop sharing so you can both share your screen and also correctly pronounce your landcare group. I'm so sorry about that one. Doesn't matter how many times you practice, does it?
That's all fine. I'm glad you made a little mistake because I'll be making lots. Thanks, Tani. Hi, yeah, Lisa. We started the Panyabar Group all those years ago, and I live at Caribou, so that's fine, all good. I hope you can see my screen. This is the area that I live in and work with. I look after seven landcare groups in this area, and it's a little bit fuzzy, the border. I work really closely with other landcare facilitators around the edges, so we swap and change with our farmers and our community. We started a project, a couple of years ago, and then we moved on to another project. So we have 27 dams in total under 2 projects that we've been working with. The first project was a threatened species grant, but Martino, I just wanted to say, before we got the threatened species grant, we applied for the drought resilience grant, and one of the aspects that we were really pushing was the fact that keeping water in the landscape longer not only benefited biodiversity and stock health, but also human health as well, especially during dry times. But we didn't get that. So we tried with the threatened species grant. And the second grant that followed from that on was the Coca-Cola Australia Foundation in partnership with Landcare Australia's Farm Dam Restoration Project. So together together with those 2 projects combined, we've worked on 27 farm dams in this area. And before we go further, I've just got to mention Hayley Glover and C. Myers from Dunkhill Pastoral Company, Landcare Victoria Incorporated, because they had to oversee our project, and Katie Selhorst from Landcare Australia. We couldn't have done all this without you. They were big projects, so they still are. And of course, I've got to mention Colleen Lomas, who is our Landcare Treasurer. She's done an amazing job managing both projects. Now, hopefully this will move on to the next slide. There we go. All righty. This is an amazing growling grass frog, and one of the very many photos that we've taken over the time of this project. Everyone sends their photos through. The growling grass frog was the subject of the first grant. It was our hero threatened species. And so our region's known for amazing populations of these critters. And having lived here for some time now, we've noticed how their populations can be quite cyclic. It follows weather patterns, which makes sense. So at the minute, we haven't got many around, but that's not, that's not surprising because we're in the middle of an extremely dry time. Same thing happened in the millennium drought quite a few years ago. We thought everything had died and or moved away. And then we got rains, and it was just amazing. Like nearly overnight, everything changed, and it became so stressful driving at nighttime because the roads were absolutely covered in these little critters. They were everywhere. I'll never forget that. So, and as we all know, how good is it to have a hero threatened species? Because improving habit for this little bloke means that you enhance the environment for so many other critters. So this one, he was photographed in amongst the plants we were going to put in around his dam. Rightio. So to help these critters and to supply a better quality water to the stock meant we needed to fence farm dams off just to prevent the stock access. So these 2 projects have been really big, and they've involved 15 different enterprises across that initial area I showed you. So we wanted to keep things as simple and straightforward as possible for the landowners as well as for us. So the thought of having 27 farm dams being worked on differently was potentially a logistical nightmare. So we engaged a contractor to build all our fences and using the same materials and the same design. So that way we could get the job done within a close time frame, and any waste is minimised, because what you didn't need in one fence you could use at the next farm. So we had our local contractor, Dale Collins Fencing. He was also an inspiration for our project because he and his wife Karen had created a magnificent wetland about 20 years ago on their farm, which all our group visited early on. It was a huge inspiration. And having one contractor here made it much easier for Colleen too, as she was the one that had to pay the bills. So it was just one bill really compared to potentially 27. Rightio. From our research, we found that having plants actively growing in and around water sources can greatly increase water quality and also offer a great food source for habitat for birds, animals, insects, fish and frogs. Haley had done some great homework and found a terrific nursery supplying aquatic species. And none of us had ever planted aquatic plants before. We've done plenty of terrestrial, but not aquatic. So it was really a steep learning curve. Steve Horton from Habitat Creations in Maui, he supplied all our plants. And again, having one supplier made everything work more simply and smoothly. We had 2,000 plants per dam, so a lot of plants came across the country. He visited with the first delivery here at this workshop that we held, and he explained to us how to do what we should be doing and also some hints and tricks that we could use. I also took my water bug kit out there so we could have a look and see what was in the water, but I got it ready the night before at home and just left it out on the deck. And by the time I'd picked it up, put it in the car and carried it out to this dam and opened it up, there was a growling grass frog sitting in the net. So they were just everywhere. It was quite amazing. I actually had one in my washing basket last week. He was sitting there in amongst the green tea towel in the wet washing that I hadn't hung out. Rightio. Okay, so planting's a huge task. We've got 2,000 plants that potentially in heavy clay soil. So we found a few ways to make it easier. But this is just a little cautionary tale. This is a dam at home, and this is my son and his mates. They came to help us, and they did a great job for 2 hours, but then we gave them a barbecue and some cool drinks, and that was the end of planning for the day. So, yeah, just a lesson. Just make sure you get a lot of work done before you sit down and let them all relax, because nothing happens after that. That means we had to finish the plants. So here we are planting the deep water plants. There's Sean, my husband. He's got his waders on, and he's got a polystyrene fruit box tied behind him with baling twine to his belt, and it is carrying the plants. He's using a long-handled shovel. In the beginning, we were putting one plant in per hole, but that was just taking forever. So we discovered that you could put 3, 4, 5 in one hole, and it seemed to work more effectively. Their roots seem to bind together with each other, and they seem to more securely fit into the soil and stay there. We've across all the dams, we've had huge trouble with birds and yabbies pulling out the plants. In some cases, it happened, nearly overnight. You'd come back the next day and you'd see plants floating. Not long after this photo was taken, the top photo, we had a huge deluge of rain, and the water level in the dam lifted to way above the plant level, the plant heads, and effectively drowned them. That was really discouraging too. So we've learned that lesson. Now we're not planting as deeply as we were then. We've had some great help from community to plant. From here, we've got the Lucendale Year 9s. We've got the CMA work crew, the Glenelg Hopkins CMA work crew helping us, family, friends and neighbours. The help we've had to do all this work has been absolutely amazing, and we're really grateful. So this is following on from what you were both saying. Research has shown that cattle can grow 23% faster when they're drinking clean water. And we all know that many stock dams are not clean. I read somewhere, and I can't remember where, but I can't remember the exact statistic, but I read that when a cow's foot touches water, there is this extremely high reaction rate to make it poo and wee into the water. And we've all seen that happen. So, and I also guess that it's not just cows that happens to either. So an important part of our project was to provide alternate water supply for stock now that they could no longer access dams. And like you were saying before, that is one of the most expensive barriers for people to fence off dams. We're also conducting long-term water quality monitoring and put up song meters and are trying our hands at making floating islands, just a tad smaller than the ones that you were doing. We've also moved and installed large rocks and timber around dams as GGFs just love basking in sun. So one project just leads on to so many others. We've had, these are all our participants, our farmers that have been fencing off their dams, and we've had such great participation and interest from them all involved. Here we're testing pH, ECs, dissolved oxygen, phosphates, temperature and turbidity. And this is an ongoing activity. So yeah, we're due to do the next round of testing right now. We've also run some farm dam and farm water workshops. Clem Sternfields from AgVic ran them, and it produced a great deal of interest. It covered topics like water quality, supply capacity and reticulation. And quite importantly, one topic was really pertinent as a couple of months later it was called into action because we needed to protect watercourses after the drought and fire. These photos were taken by Christian Bell from when he was at Deakin Uni under the Blue Carbon Survey in May 2024. It's one of our dams, and this particular dam's not fenced, but the way we're running our cows now, they're all in one mob, and they might only come back to this place, this paddock in, I don't know, every 6 months. So when that happens, we just run an electric string with tread-in posts around the dam to keep the cows out of it. I'm not sure if you can see that emu having a beautiful swim there, and how wonderful it was to find the brolgas there visiting as well. That was such a sight. Radio, summer 24-25, the Grampians fires happened. Here's our fire truck Caribbeal with the grains truck that was up at Miranatwa on Christmas Day, just waiting for the fires to come out of the bush. The information we gained from those earlier workshops with Clem and from the knowledge and advice from the Glenelg Hopkins CMA and the Southern Grampian Shire all came into use as we worked with fire-affected people to protect their dams and waterways from sediment pollution. The CMA works crew set up koi logs to slow and filter runoff from the burnt hill paddocks and help plant aquatic plants back into the dams. And you'll notice here that we've started to protect the plants with large, sturdy guards because we've had massive grazing pressure from both birds and animals. Everyone was so helpful and supportive in what was such a traumatic time for a lot of people. Another unimagined offshoot from our project was the involvement with Deakin Park, Spic and Austral during the Grampians fires. There was a fear that a blackwater event would happen along the Wannon River as it was virtually burnt all the way from its source at Mount William down to the south. River blackfish breed there happily, but their population would have been decimated if the already low flow, river flow was impacted by bushfires. So we put a call out to the local community looking for surrogate dams to house the fish until the threat receded. And we were just inundated with offers of help. And these weren't just the farm dams that we've been working with. These were extra dams. To check that the dam was suitable, Austral and Deakin conducted DNA tests to look for the presence of predator fish like redfin. And they also checked for the available food supply, which is that little tray there full of, you can't see anything, but it was absolutely bursting at the seams with little bugs. The plants, and they also did general water quality. They made safe houses out of bundled sticks, and they tied those together and put them in, tied them to stakes in the dam. And they also used those bioblocks, which is the top right, which are small long cylinders bundled together just like a big apartment building, because these fish like to be on their own. They don't like sharing with others. As part of our Coca-Cola Australia Foundation and Landcare Australia project, we're also going to be sowing native grassland species as well. We're putting some taller trees and shrubs around the dam, but we're keeping them back from the water body itself, as the GGFs just love sunbaking and we don't want to create too much shade for them. So we're also thinking that our water plants will help in shadowing the water as they grow, which will lower the temperature, slow the wind speed and reduce evaporation. So in effect, they'll be doing the part of, they'll be playing the part that the terrestrial plants would have been doing. We're working with renowned native grassland expert, Dave Franklin from Wandoo. He's advising us, he's supplying the seed and he'll be establishing the sites. But this project, this part of the project's been delayed because, as you know, we're all going through an extended dry period, which has affected seed production and establishment. But it will happen, and we have our fingers crossed that we'll be sowing April, May this year. Hang on, there we go. So these are just an example of what the dams are looking like at the minute. Pauline's over there on the left conducting a water test. And this is the same dam that we had in an earlier photo where the year 9s had been planting. The picture below is where the blackfish were, but they've been collected now and returned to the one, and so that's okay. And the large picture on the right, well, with the last turtle to leave, please shut the gate behind them. It's pretty dry. So this is the same blackfish dam a couple of years ago. So this is so good to have the photos to remind you of what it was like and what it can be like in the future. Where at the minute all we see now is dry clay and cracks, but this is so good to see. Again, more photos to remind us of what it can be like. This is our pet GGF. He keeps appearing in different places around our garden, and here he is amongst the French sorrel a couple of weeks ago. And then on the right, pardon me, it's very fuzzy, but that's a picture taken at night a few years ago of an example of just down the road what it was like trying to drive down the road at night time with all the growling grass frogs sitting on the road. Sorry. And here, this fuzzy photo, this is Dale and Karen Collins' farm that I was telling you about before. They fenced and re-vegged their wetland about 20 years ago, and it was so inspirational for our group to go out and have a look at it before we actually started our own projects to see just what we could hopefully achieve, hopefully in 10 years. Sorry, more growling grassfrog photos. I've become infatuated with them. Again, these are in our backyard, sunning themselves in the midday sun, which is so unfrog-like, I would have thought. Thanks for listening, and again, thanks to everyone that's helped us with these projects. We've really appreciated and enjoyed their support, knowledge, and connections, and it's leading on to so many other projects now, and also to protecting more dams. Thanks.
Thank you so much, Lisa, not only for the pictures of frogs, but for all your fabulous knowledge as well. I want to just start by asking you a question, which I think yourself, Jen, and Martino all talked about the impacts of drought and fire on dams. Do you have any advice for dealing with dams in drought? Is there anything you can do to protect your dam when you know you're going into drought? Is there anything you can do when you're coming out of drought? Any tips for those that may be watching dams dry up now?
Fence them off and put a trough in. It's not, there's no silver bullet. It's a journey, and I think, at the moment we got $6 kilo beef, we got $11 kilo lamb. We have to be strategically investing in getting the livestock out of those dams. It fails at every turn. Dirty water, muddy water, stuck livestock. Normally, the energy in the animal is low during dry times. The feed quality is down, and so just fence them off. Whatever your motivation is, whether you're excited about frogs, whether you're excited about money, whether you want to trade beef in the future and have a farm that has biodiversity, fence them off.
Lovely. Anything to add, Lisa?
No, that's perfect. Frogs and income is is very important. So yeah, no, fence them off. And golly, we've had our fair share of pulling stuck weaners out of farm dams. Like it does no good to your morale or your back as well. So yeah, it's such a good thing to do.
Absolutely. Martino, I want to go to you next. We've got a question from Megan, who's a wildlife rescuer, who's had a few issues with mammals trying to access water sources that have been fenced off. Do you have any advice for those that want to be able to fence off farm dams but still protect native wildlife while doing it?
Yeah, good question. So typically the fandoms that we deal with are for cattle, so they require very simple fencing, typically electric fencing. So yeah, those type of fencing, the kangaroos don't seem to mind too much. They can go in and out with no problems. Definitely avoid barbed wire. But yeah, I mean, wildlife will tend to go through if it's a simple fence. Yeah, but every situation is different.
And I know depending on your location, you may be using different fences and you may be using different tree guards. Again, your local landcare group is always a great point of contact to figure out what works in your local area. I've got another question here about fencing, but it's virtual fencing from John. What are the applications of virtual fencing in terms of fencing off farm dams? And for those that may not be aware, what's virtual fencing?
Yeah, so I've been thinking about virtual fencing because in theory, they could be a great alternative and potentially even reduce the cost. So what virtual fencing is, well, you put a collar around your livestock and it has a GPS, and whenever this GPS is detected in a certain area, it will try to deter livestock using typically small electric shocks, so then livestock will avoid going in there. So it's more like a behavioral training. To be honest, I don't think around here I haven't heard of many people using it, so I don't know how good they are. The concept sounds good, but I'm not sure in practical terms how useful they are. Also, another thing is many farmers tell me that whenever you install a trough with clean water and it's next to, say, like an open farm dam, typically livestock prefer the trough. So sometimes there is not even need to have a fencing. Like there is literally like livestock tend to prefer the trough water over the farm dam water. So there are options there in alternative to the traditional fencing.
That's great
I can
to
add
consider.
something on the virtual fencing. So we're considering virtual fencing for increasing pasture utilisation within high intensity cattle farming. There's a virtual fencing project with the University of Adelaide through MLA. So people are interested in that. That's really worth following. There's also a virtual fencing demonstration at the Allen Bank Smart Farm as well in Warragul. We've talked with an investor about using virtual fencing to fence off particular like lots of gullies and where the fencing structure is going to be quite complicated, lots of strainers and posts and assemblies to fence around all the gullies and deep spots and things. They're absolutely not interested in doing that. You think about the investment in the vegetation, like the weed control and the planting and establishing the plants. If the virtual fencing system goes down, phone connectivity, or if things go wrong with it, then you lose all of that asset. The asset is the vegetation that takes 2, 3, 4 years to build basic resilience to even a small number of livestock getting on that riparian area around the stream or the creek. So I don't believe that it has necessarily an application in that stage as yet, while we're still relying on that satellite connectivity and still developing that product. In saying that, virtual fencing is very, very exciting, I think, for lots of applications in agriculture.
I guess it's always the way with new technologies. You have to wait for some of the bugs to be ironed out before they're 100% ready to go. I want to go to Melinda's question next. This is related to floating vegetation on farm dams. Martino, with the platforms you were talking about, have you thought about dual purposes, looking at both habitat for vegetation, but also for ducks and turtles and other semi-aquatic species?
Yes, yeah, the program that we are running now with Melbourne Water in the Bath Coast is looking at both. We are still, well, at early stages. We started the program like probably a month ago. So yeah, we're monitoring the carbon, but also the biodiversity. What we notice is that yeah, well, floating wetlands attract a lot of birds. That is good and bad in a way because in terms of water quality, that could also attract a lot more input of organic material. Also, the type of birds that are attracted to a farm dam depends on the condition of the farm dam. Like the typical like ducks will tend to favor open farm dams because they like long landing strips, and so they don't particularly like too much vegetation around, or at least they don't seem to mind as much. While many other species of birds will prefer habitats with a lot of vegetation and complexity because of they need the habitat sheltering and all the rest. So it's not just a matter of quantity, but also the quality, like the type of wildlife. So yeah, work in progress thing.
No, it'll be great to learn more as your team continues researching all these great new measures. Lisa, I want to go over to you. We have a question from Christine, who has a new farm dam in the Riverina area. Any advice for plants that grow well in heavy clay soils? Um,
Well, yeah. Well, it depends on where you're planting them, really. Like if you're planting them inside, underneath the water, or around the edges. I think the best thing to do would be have a chat to your local nurseries, because what might work down here in the south could be different to what works up there with you guys. But I think the main thing is the protection against birds and yabbies and grazing animals. So if you can use rocks or logs or something like that to anchor these plants into your dam edges, I think that your survival rate will go up a lot, will be a lot better than the ones that we've been putting in without any protection, because they just haven't lasted. So yeah, try and anchor them as well as you can, as well as digging the hole. If you put some rocks or some logs or stuff around it, just to stop that pulling out before the roots get a chance to establish within the soil, I reckon you'll go really well with whatever you decide to plant around there. Yeah, that's the biggest issue that we're finding.
um, okay, I've also just got a question from Mark here. I guess this could go to yourself, Jen, Martino. How do you stop birds using the water troughs and fouling up the water? I think Mark's had some issues with ibises, ducks, and others.
I guess I don't know. We probably haven't really kind of noticed that issue. The trough design we use is kind of large and open. I feel like the birds, like they're not the big round troughs. They're sort of long rectangular troughs. So the birds, I'm imagining, would land on the sides with their asses pointing out, and their faces pointing in to drink. I guess if you move away from those large round troughs, that's a way to avoid them landing in the water and floating on the water. But yeah, not necessarily something we've had a lot of challenge with.
Awesome. Thanks, Jen. I want to also I'm sorry, I know I'm rapid firing these questions. I know we've only got a couple minutes left. Martino, we've got someone asking advice here. Charles wants to know if you should start considering fencing off your farm dam in a drought or whether you should wait for a good year. And then which season should you start planting?
Oh, yeah, have. I don't know. I would need to think about it. I feel like there are advantages of fencing off in a good year. I'm thinking about the vegetation here. Um, yeah, and yeah, and to be honest, I think in a drought, there are a lot of complications going on. So I would imagine there are a lot of competing activities. So I'm not sure. A drought is often a very stressful period. Um, yeah, yeah, I'll need to think more about this.
Could I make a suggestion?
Of
Yeah.
course.
Um, When we started, it was recommended that we plant in autumn, because that was traditionally when the dam height was lowest before the influx of water through winter and spring. But we found that it was just so hard to try and dig holes in a dam bank in autumn. So we're moving over to into spring, and it gives you probably a bit more of an idea about water levels. But yeah, like it was just really hard to get any sort of tool into the ground at that time of year. And yeah, like any time's a good time to fence a farm dam. You don't have to wait for a good year or a bad year. It's amazing. Once you take the grazing pressure away, it's amazing, even if it's dry, what might grow after the stock pressure's been taken away. So
Yeah, we've probably got contrasting experience there. So down on the red gum plains, fence it off, get the stock off, and what they say, like red gums and kangaroo grass and wallaby grass and everything just comes up regardless of the season. Up in the high country, like a sort of more granite-based loamy soil, those hills have been fairly well grazed within an inch of their life for a very long time, and nothing grows. So we've found that we've really had to plant those plant communities back. So if you want to know though what is going to grow up, make yourself up a pasture cage or find an old trailer, an old trailer cage or something, put it over a patch so that you can get the livestock pressure off it, and get some water and water it, and just watch it for the next 12 months, and you'll see if there is a seed bank there, if there is something that's going to come up, you're going to know what's going to happen and what's going to look like when you get that stock pressure off it.
That's great advice, Jen, and a wonderful reminder that we do often have native seed banks that are available and flourish when given the opportunity. I know we've just hit past 7. I just want to really quickly go to our presenters and thank them all for sharing their wonderful experience and ask if they have any passing pieces of advice. Jen, you're largest on my screen, so I might handle to you first.
Yes, I've just put on the chat. There was a question earlier about, what plants suit. So if you're keen on AI, which I am, look up your ecological vegetation class for your area. It'll give you a class. It'll tell you what plants, and then put in what your soil type is. What plants from that list suit your soil type? So if it's a sandy loam or a clay loam, or if it's a hard clay, and you'll come up with a really good list of plants that suit. And then take that list to your local landcare group, join up, and get involved.
Great advice there, Jen. Lisa, any final words?
No, except well, it's just such a wonderful project to be involved in, fencing a farm dam for all sorts of reasons. And probably carbon was at the lowest reason why we did it, or carbon potentials. But yeah, it's so good for everybody to do this type of project.
Absolutely. And last but definitely not least, Martino, any final words?
Yeah, no, thank you very much for organizing this. This is great. As always, I learned a lot by listening to other people. One thing is, I've heard great things about apparently there are data connecting water quality with productivity. Yeah, I was listening to Jen, and I think Lisa, you also talked about that. Please reach out. I would love to get an analysis on what is the estimated productivity benefit. So anyone that has data set from their farm showing a connection, please reach out. If I could get this data set published, peer reviewed and published, I feel like it will lead to some good repercussion and good impact down the track.
Absolutely. If anyone wants to reach out to Martino, please email myself. I know his email was also in the presentation, and I'm sure you can all join me in thanking our presenters today. It's been such a fabulous discussion. As with all of these webinars, I personally learned so much and really appreciate all the different perspectives that our panelists have brought. I know I shamelessly have to nag all of you to please fill out some feedback surveys that'll pop up after this webinar, and also remind you that the Carbon Farm Farming Outreach Program has 1 month left of delivery, so we still have a whole range of awesome activities happening all over the state. So please have a look at our Landcare Victoria webpage. We've got a whole bunch of different resources, previous webinars and events to help you answer some of these questions and address your carbon confusion. So really happy to have you all joining us today, and thank you all so much for your time. I hope you have a wonderful evening. Thanks.
Bye, everyone.
Thanks.
Thanks, Tani.
Cheers, everyone.